Hello friends and dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 8 video from the chapter of force and pressure, where I will solve 5 multiple choice questions based on the concept of thrust and pressure that I discussed in part 7. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So in this playlist I only discuss concepts and formulas that are related to numerical problem solving of physics class 8 from based on based on ICSE board. Okay, so the first problem says that there is a figure. It says multiple forces, each of magnitude F Newton, is applied on a surface of area y meter square at different directions. The pressure exerted on the surface is, we know that we only consider pressure is only exerted by a thrust, which is a force acting perpendicular or normal to the surface. Clearly, how many of these forces are normal to the surface? We have this one, this force, this force, this force, and this force. The other two are not normal to the surface. So the total force acting on the surface of the earth, the total thrust acting on the surface is F plus F plus F plus F, which is equal to 4F. This is the total thrust. Okay, so clearly pressure we know is equal to the force, the thrust, divided by the area of the surface contact where the thrust is acting. So we have 4F. The surface area of the surface of contact is given to be y meter square. So this is y meter square, and of course the total force is 4F Newton. So this is 4F Newton. So this becomes 4F by y, this much Newton per meter square, which is equal to 4F by y Pascal. 4F by y Pascal is the pressure exerted on the surface. So the correct choice is D. D is the correct choice. Now one thing I would like to say, that if I do any kind of silly mistake or apply incorrect concept or apply concept incorrectly and do anything, do any kind of any other mistakes, then please feel free to let me know in the comment section. I will appreciate that, and I will do my best to address your queries. Let's see the next problem. Okay, in the above figure, a solid cuboid of side length x meter. So we can clearly see the left hand side figure is a solid cuboid, the middle one is a cone, and the extreme right is a cylinder. Okay, so in the above figure, a solid cuboid of length x meter, a solid right cone of diameter 3x by 2 meter and height x meter, a right cylinder of radius 2x by 3 meter and height 3x by 2 meter are resting on a surface as shown. Okay, all the solids have densities rho kilogram per meter cube, 2 rho kilogram per meter cube and 3 rho kilogram per meter cube respectively. Arrange the pressure P1, P2 and P3 created by them in ascending order. Okay, so P1 is the pressure created by the cuboid, P2 is the pressure created by the cone, and P3 is the pressure created by the cylinder. To find the pressure, we need the total thrust or force acting normal to the surface and the area of surface of contact. Clearly for the cuboid, the area is the area of one surface. The dashed line is indicating the surface on which the solids are resting. the cone is resting on its base, which is circular. The right cylinder is also resting on its base, which is also circular. Okay, so now how do we know the pressure? How do we know the force, thrust? It will be basically based on the weight of all the solids, and the weight will depend on the volume and its density. Okay, so let's do it step by step. Let's say I am calling V1 to be the volume of cuboid. So V1, we know the volume of cuboid is side to the power 3. So it will be x cube meter cube. Okay, what will be the volume of the cone? The volume of cone we know is one third pi r square h. 1/3 pi r square h, where r is the radius of the base, circular base. In this case, the base is given to be the diameter is given to be the diameter of the base of the cone is given to be 3x by 2 meter. So its radius will be 3x by 4. So 3x by 4 square pi r square h, and the height of the cone is given to be x, which is equal to this will be equal to now okay 9, so 3 pi x cube by 16, 9 16. Okay, so this is the volume of the cone. What is the volume of the cylinder? The volume of cylinder is pi r square h. So pi r is the radius of the base. In this problem, the radius is given to be, the diameter is given to be 2x by 3. So the radius is x by 3. So x by 3 pi r square h. The height is given to be 3x by 2. 3x by 2. This is equal to 9 3. So pi x cube by 6. Pi x cube by 6. Okay, this much meter cube. V2 is this much meter cube. Okay, so we have found the volume. Now what will be the mass m1 of the cuboid? It will be V1, and its density is given to be rho kilogram per meter cube. So rho this much kilogram, which is equal to V. This is equal to rho x cube kilogram. Okay, let's see what is a mass of the cone. Its volume multiplied by its density. The density of cone is twice rho. This much kilogram. This is now V2 is 3 pi. So this becomes 3 pi x cube twice rho divided by 16. This much kilogram. So this is equal to okay, so this is equal to 3 pi x cube rho by 8. Okay, this much kilogram. And what is the mass of the cylinder? It will be V3, and its density, which is thrice rho, this much kilogram. And V3 is pi x cube by 6 multiplied by 3 rho kilogram, and this is equal to pi x cube rho by 2 kilogram. Okay, so we have the mass. Now obviously we know that the thrust or the force exerted by all the solids on the surface will be equal to their weight. Now, so therefore, what is weight of or the thrust weight of the cuboid? It will be m1 kgf. I will not convert them to Pascal because the problem has only asked to compare P1, P2 and P3. Okay, so it is not necessary to convert them to a particular unit, but all the units of all P1, P2 and P3 has to be same. Okay, so W1 is M1 kgf, fine, and okay, let it be in kgf. Okay, so this is equal to rho x cube kgf. What is W2? W2 is equal to M2 kgf, which is equal to 3 pi x cube rho by 8 kgf. And what is W3? Weight of the cylinder. This will be M3 kgf. This is equal to rho x cube pi x cube rho by twice by 2 kgf. Okay, so now what will be pressure P1? It will be W1 by what is the area. I forgot to compute the area of all the bases, area of all the surface where on which the three solids are resting. Okay, so area of the cuboid is area of a face, which is will be x square. So this will be x square. This much, okay, which is equal to rho x cube kgf divided by x square. Now x square will be in meter square, so this becomes rho x kgf per meter square. I will keep the unit of the pressure in kgf per meter square only. Okay, so rho P1 is this. Okay, let's see what is P2. Pressure exerted by the cone on the base. The area of the base is the area of the circle, and the circle is having a radius of 3x by 4. So P2 will be W2 divided by area of the base of the cone is pi r square. R is 3x by 4. 3x by 4. So this is equal to W2 is, what was W2? 3 pi x cube rho by 8. This divided by this will be 9 pi x square by 16. So this was kgf, this was meter square. This after simplification will be pi, okay, pi cancels out. Okay, what it will be? I think it will be 2x rho and divided by 3. This much kgf per meter square. 2x rho by 3. Okay. P1 was rho x kgf per meter square. P2 is 2x rho by 3 kgf per meter square. Let's see what is P3. P3 is W3, weight of the cylinder, and what is the base area of the base, that is the area of the surface of contact, is a circle, and the circle is having a radius of x by 3. So this will be pi x by 3 square. this is kgf, and this is meter square. So this becomes W3 was pi x cube rho by 2. This much kgf divided by, we have pi x square by 9 meter square. This after simplification becomes 9x rho by 2 kgf per meter square. So we got P1, P2, P3 as kgf per meter square. Now we have to compare. We have to compare rho x, whether rho x is more, or 2x rho by 2x rho by 3 is more, or 9x rho by 2 is more. So we can easily ignore the rho x, and we can compare whether 1 is more, or 2 by 3 is more, or 9 by 2 is more. Clearly we can see that 2 by 3 is less than 1 is less than 9 by 2. So this implies 2 by 3 is the for pressure. So we can say pressure P2 is less than 1 was P1. P1 is less than P3. So this should be the ordering of the pressure created by the solids. P2 less than P1 less than P3. P2 less than P1 less than P3. So the correct choice is choice D. D is the correct choice. Okay, let's see the next problem. There are two figures A and B. Okay, in figure A, 3 weights are stacked and resting on a surface of area A meter square, and pressure created on the surface is 6 Pascal. In figure B, a weight of x kilogram is resting on a surface of some area of same area A meter square. What is the value of x if pressure created in figure B is 8 by 3 Pascal? Okay, now for the figure A, what is the total force acting? Since there are 3 weights stacked on top of each other, clearly the weight of all the 3 weights will act vertically downwards on the surface. So the total weight will be 5 plus 3 plus 1, which is 9 kilogram. It effectively the thrust or the force will be 9. So the weight or the thrust or the force acting normally to the surface will be 5 plus 3 plus 1, this much kilogram force, which is equal to 9 kilogram force. Okay, and it is given that in the figure A the pressure created is 6 Pascal. So from the formula pressure is equal to force by area, I can say that 9 Pascal is equal to 9, force is 9 kgf divided by the area is given as A meter square. So A meter square, from this equation I will get A. Now I have to be careful because the pressure on the left hand side is in Pascal and on the right hand side I have kilogram force. I will first convert kgf to Newton. So this is 1 kgf is 10 Newton. So this will be 90 Newton divided by A meter square. Now I can say this will be 90 by A Newton per meter square, or this is 90 by A Pascal. Now I can say that 9 is equal to 90 by A. This implies A is equal to 90 by 9, which is equal to 10 meter square. So we have found the area of the contact surface, which is 90 meter square. Now for the figure B, for figure B, let's see what is happening. It is given, so we know A. It is asking what will be the value of X. So the pressure, so the thrust will be the weight of the body of mass X kilogram. So we have applying pressure is equal to F by A will imply what is the pressure? Pressure is given to be 8 by 3 Pascal is equal to what is the force? Force we don't know because we have to find X. Force will be X kgf divided by A we know as 10 meter square. This is equal to 10x, since 1 kgf is 10 Newton, this will be 10x by 10 8 by 3 Pascal. Okay. So this is pressure is given to be 8 by 3 Pascal. The force will be the weight of the body, which is X kgf, and area we have found to be 10 meter square. So this is coming out to be 10x by 10. This is 10x Newton meter square. So this is coming out to be X Pascal. So this will definitely imply that X is equal to 8 by 3, which is not given in the choices. I will quickly check whether I did the calculation correct or not. In the first, in case of figure A, the total weight is 9 kgf. Okay. So 9 kgf divided by A meter square is the pressure. That will be 90 N by A meter square. That is 90 by A Pascal. And this is given to be 6 Pascal. Sorry, in the figure 1 it was not 9 Pascal but 6 Pascal. So this is 6. This is 6. So I have this is 6 is equal to 90 by A, or A is 90 by 6. 90 by 6. So this will be 15. A is 15 meter square. So I have over here 15. 15. So this becomes 10x by 15 Newton per meter square. This becomes 2x by 3 Pascal. So this implies that so we can say that now 8 by 3 Pascal is equal to 2x by 3 Pascal. So we can say 8 by 3 is equal to 2x by 3. This implies x is equal to 8 by 2, which is equal to 4. So x is 4. So the correct choice is D. D is the correct choice. Let's see the next problem. If 1 Newton per meter square is equal to x Pascal, 1 kilogram force per meter square is equal to y Pascal, 1 gram force per centimeter square is equal to z Pascal, and 1 dyne per centimeter square is equal to P into 10 to the power minus 7 Pascal, then which of the following choices is correct? So basically we have to find x, y, z and P. Okay. Now 1 Newton per meter square we know is nothing but 1 Pascal. So this implies that x should be equal to 1. At this stage I can right away reject the choices C and D. Okay. Okay, so let's see what is 1 kgf per meter square. If I want to convert it into Pascal, so this is 1 kgf divided by 1 meter square. 1 kgf is 10 Newton. 10 Newton by 1 meter square. This becomes 10 Newton per meter square, which is equal to 10 Pascal. So clearly this implies that y is equal to 10. Y is equal to 10, and at this stage only I can right away reject the choice B. So the correct choice is A. Correct, A is the correct choice. Let's see now, for the sake of completeness. So for the sake of completeness, let me also do the other formula, that is what will be 1 gf per centimeter square in Pascal. This is 1 gf, 1 gram force divided by 1 centimeter square. 1 gram force I know is 10 to the power minus 3 kgf, kilogram force, and 1 centimeter square I know is 10 to the power, my machine is running pathetic, 10 to the power minus 4 meter square. Okay, again 1 kgf is 10 Newton, so this becomes 10 to the power minus 3 multiplied by 10, this much Newton, divided by 10 to the power minus 4 meter square. So this becomes 100 Newton per meter square. This is equal to 100 Pascal. So this implies that Z is equal to 100. How come Z is 10 to the power minus 6? X is 1, Y is 10, okay, and Z is, how come Z is 10 to the power minus 6? Uh, 1 gram force per centimeter square is 1 gf divided by 1 centimeter square. 1 gf is 10 to the power minus 3 kgf, okay, and 1 centimeter square is equal to 10 to the power minus 4 meter square. So this becomes 10 to the power minus 3, 1 kgf is 10 Newton, so 10 to the power minus 3 multiplied by 10 divided by 10 to the power minus 4, this becomes 100 Newton per meter square, which is 100 Pascal. So Z should be 100. Z should be 100, so the choice A, this is given wrong. Anyway, so I have incorrectly given the choices. I am really sorry for this, but Z is 100. Z is 100, X is 1, Y is X is 1, Y is 10. Let me see what will be P. So 1 dyne per centimeter square is equal to 1 dyne divided by 1 centimeter square. Now 1 dyne is 10 to the power minus 5 Newton, and 1 centimeter square is 10 to the power minus 4 meter square. So this becomes 1 by 10 Newton per meter square. This is 1 by 10 Pascal. 1 by 10 Pascal. 1 dyne per centimeter square is 1 by 10 Pascal. So we must have P multiplied by 10 to the power minus 7 is equal to 10 to the power minus 1. So this implies P will be equal to 10 to the power minus 1 divided by 10 to the power minus 7. This should be 10 to the power 6. P should be 10 to the power 6. let me see if I am doing it correctly or not. 1 dyne per centimeter square is 1 dyne divided by 1 centimeter square. Now 1 dyne I know is 10 to the power minus 5 Newton. I hope I am correct that 1 dyne is equal to 10 to the power minus 5 Newton. 1 dyne is 1 gram centimeter per second square. 1 gram is 10 to the power minus 3 kilogram, and centimeter is 10 to, yes, it is fine, and 1 centimeter square is 10 to the power minus 4 meter square. So this becomes 1 by 10 Newton per meter square, which is 1 by 10 Pascal. That is fine. So 1 dyne per centimeter square is 1 by 10 Pascal. It is given that 1 dyne per centimeter square is P into 10 to the power minus 7 Pascal. So P into 10 to the power minus 7 should be equal to 10 to the power minus 1. So P will be 10 to the power minus 1 divided by 10 to the power minus 7, which becomes 10 to the power 6. P is 10 to the power 6. Anyway, I have given all the choices garbage. I am really sorry for this, but I hope you are getting the idea how I am converting from one unit to another unit, applying the concept of conversion of fundamental units and the formula of pressure. Let's see the next problem. Okay, so this seems to be a conceptual theoretical problem. It says which of the following statements are correct about thrust, area of contact and the pressure. Okay, so we know that pressure is equal to the force or thrust, that is the thrust, that is the vertical force on the surface of contact divided by the area of the surface of contact. Okay, choice A is saying for constant F. Okay, so for constant F, this is the formula. From here we can say that if F, that is the force, thrust is constant, we can say that P will be some constant K, where this K is the value of the magnitude of the constant force by A. So this implies that P is inversely proportional to A, that is the area of contact. So clearly, if A is more, then P will be less. If A is more, P will be less. So clearly, this is an incorrect statement. And so if A is more, P will be less. So this is the correct statement. For constant F, more A implies less P. Let's see C and D. It is related to constant P. Now in this formula, P equals to F by A. If I consider P to be constant, that is pressure is constant, I will have some constant K, where K is the constant value of the pressure, to be equal to F by A. This implies F is equal to some constant into A, or in other words, I have F by A. F by A is a constant. This means that F is directly proportional to A. When two quantities, this is from the concept of variation, direct and inverse variation from mathematics. If F and A are two quantities, and if F by A is a constant, it means that the two quantities F and A are in direct proportion. So we must have F is directly varying with A. Okay. So quite obviously, if A is more, F will be more. If A is less, F will be less. So C is saying for constant P, more F means less A. This is false. And choice D is saying for constant P, less F means less A. This is correct. So choice B and D are correct. So this brings to an end in solving 5 multiple choice questions on the concepts and formula of thrust and pressure that I discussed in part 7 video. I hope this video will be beneficial in clarifying and evaluating your understanding of thrust and pressure and the units of pressure from the last video. If you find it beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will discuss about the pressure exerted by various solids and liquids, and how do we quantify the pressure exerted by a solid body, and pressure exerted by a liquid, and what are the factors of the liquids in a container that affects the value of the pressure. All these things with a little bit of numerical aspects I will discuss in the next video. So please stay tuned for that. I will end the video here. Thanks for watching, and until the next video, take care and bye.